Okay guys, section 3.2 is where we're going to start working on truth tables. Today we're going to learn how to do truth tables for negations, which is remember your tilde, truth tables for conjunctions, which it means and truth tables for disjunctions, which means or. A truth table is just used to analyze a compound statement and to tell whether or not the compound statement is in fact true or false when you go through the analysis procedure. So the easiest one to work with is going to be the negation. Okay, so when you deal with a statement, and the statement is a simple statement, statement P, there's either two cases. The statement can be true or the statement can be false. For example, my car is blue. That is either a true statement or a false statement depending on what my car actually is or not. When you're doing a truth table, sometimes the statement will be negated. And when you do a negation, all you have to do is in the truth column, change all true answers to false answers and change all false answers to true answers. And you'll have represented the negation of the statement. If you have a compound statement, that would be two phrases said together. For example, you could talk about my car is blue and my car has tan interior or something like that. Then there's four different things that could be true. Either both statements could be true. The first one could be true and the second one could be false. The first one could be false, the second one could be true. Or they both can be false. Just so you know, I've got a little hint for when you have to do these. Depending on how many statements you have, all you have to do is take 2 and raise it to the number of statements, and that will tell you how many different options that you can have. And then when you go to make your options, so for example, there was 4 possibilities in here, then your first column you would list 2 trues and 2 falses, and then you would, in your second column, you would go every other. Okay, so for example, let's just say that you had a P, a Q, and an R. That is 3 statements, so you would have 8 possibilities. So under your P column, you would list 4 trues and 4 falses. And then in your Q column, you would cut the 4 in half and do 2 and 2. 2 true, true false, 2 true, 2 false. And then in your R column, you'd go every other. True, false, true, false, true, false, true, false. And that would give you all the possible ways that the statements could be combined. Okay, now that you have the ability to make 2 statements, you need to analyze whether the 2 statements are true together or not. So remember, if they use the little carrot looking guy, that means and. So we want to know when P and Q are both true. Okay, so there's only a time when P and Q are true. In order for that to be the case, both P and Q has to be true in order for the conjugation to be true. If either of P or Q or both of them are false, then the statement will be false. So the only time a conjunction is true is when both P and Q are true. If they use the word or is a little bit easier. The only time that an or is false is if both P and Q are false. Otherwise, an or will always be true. As long as one of them is true, or will always come out to be true. Now, those 3 tables I just showed you, you need to get those memorized, or you need to put them in a notebook somewhere close to where you are going to be when you make your truth table. Okay, so for example, this is a pretty complex example, but it'll show you every option in here and how to construct it. Okay, so I would like for you to construct a truth table of the negation of Q or P. And notice they didn't tell you what the Q or the P stood for. It honestly doesn't really matter, and you don't even need to look at it. Okay, so I'm going to scoot this up a little bit so that we have some room. Okay, so I have 2 statements. I like to go in alphabetical order, so I typically list P first and Q second. because that's how I do it. Since I have two statements, I am going to have 4 lines. So if I start with my P, I'll do 2 trues and 2 falses. And then with my Q, I'll do every other. True, false, true, false. Okay, so it's a lot like order of operations. You want to get what's done in the parentheses first. So the first thing I'm going to do is figure out what my negation of Q is. Okay, so the negation of Q is just going to be the Q column reversed. So instead of true, I'll put false. Instead of false, true. Instead of true, false. Instead of false, true. And I have my negation of Q. Now, I need to do the negation of Q or P. So I'm going to have to look at the negation of Q column. So the first entry is false. Then I'm going to have to look at the P column. The first entry is true. And I'm going to have to remember my ORs. So in my ORs, as long as one of them is true, they're all considered, then that statement is considered true. So because I have a false, true, I have at least one true, so I can put a true. I have a true, true, so I can put a true. I have a false, false, that's bad, false. I have a true, false, and that would be true. And I'm getting those values off of that table that told you about the conjunction. As long as one statement is true in the conjunction, then the whole statement can be true. Okay, now I've completed everything that's in the parentheses. I've completed the negation of Q or P. So now I need to do the negation of that. So I need one more column. I need to do the negation of the negation of Q or P. So all this means is to take the column I just found and make everything the opposite sign. So instead of true, true, false, true, I'm going to have false, false, true, false. And this would be my answer. Okay? Here's another example, if you want to see another one. The negation of P and the negation of Q. So again, you're going to want to start it off the same way. You're going to look and see how many statements have been made. There's 2 statements listed. There's statement P and there's statement Q. So I'm going to start with that. I'm going to scoot this up a little bit. Okay. So I have statement P and I have statement Q. Since there are only 2 statements, I only need 4 lines in my table. And I'm going to start with true, true, false, false, true, false, true, false. Like that. Okay, now I need to calculate the negation of P. Okay, so that just tells me to go to my P column and do the exact opposite of what appears in my P column. So instead of true, true, false, false, I'm going to have false, false, true, true. I also need the negation of Q. So go to my Q column and do the exact opposite. So instead of true, false, I'm going to have false, true, true. And then last, I need to calculate the negation of P and the negation of Q. So I'm going to look at those tables about the conjunction. Remember, the only time the conjunction is true is if they are both true. So I have a false, false, a false, true, a true, false, and a true, true. So my true, true is good. I have one time when they are true. And so this would be your truth values right here. This is the only time that statement would be true. Okay. Sometimes you can use truth tables to prove a statement true or false. You have to kind of dissect it a little bit, but I can show you an example of that. So, for example, determine the truth value for each simple statement. Then using these values, These truth values determine the truth value of the compound statement. Okay, so first of all, you have to break it up into simple statements, okay? The statement is 15 is less than or equal to 9. Okay, so we actually have two statements there, although it seems odd. Our first statement is that 15 is less than 9. And our second statement is that 15 is equal to 9. Okay, so if I was going to translate the expression 15 is less than or equal to 9, I could put P or Q. Okay, just like that. Actually, let me erase that. Okay, so if we were going to make this look like a truth table, I would list my P and I would list my Q. Now, I don't have to list all of the options. I don't have to list all 4 because I know whether P is true or not. 15 is less than 9 is a false statement. 15 is equal to 9 is a false statement. So then if I use my or P or Q, I know that the only time I get a false statement for P or Q is if both P and Q are false. So this would be a false statement. 15 is not less than or equal to 9. False. Let's make it a little more complicated. Let's look at the next example. Okay. Determine the truth value for each simple statement, then using these truth values, determine the truth value of the compound statement. George Washington was the first United States president, or Abraham Lincoln was the second United States president. But there has not been a United States president born in Antarctica. Okay, so you may not know whether those statements are true or not, and that's fine, but we're going to start by dissecting it. So let's move it out of the way here a little bit. I'm just going to scooch it up. Okay, so the first statement is made about George Washington, so we'll let that be P. The first one is that George Washington was the first U.S. president. So George Washington was first U.S. president. Okay, our second statement is about Abraham Lincoln. Abraham Lincoln was the second U.S. president. And our third statement is about Antarctica. Our third statement was that a U.S. president was born in Antarctica. U.S. president born in Antarctica. Okay. All right. So if we're going to set up our truth table, we want to make sure we know what statement we're setting up. Okay. So let's read this again. It says George Washington was the first United States president, or Abraham Lincoln was the second United States president, comma. Okay. So that means George and Abraham have to go on the same side of the equation with parentheses around it. So it was George was the first, or Lincoln was the second, comma, but there has not been a U.S. president born in Antarctica. So remember, the word but is another way of saying and then they said there has not been, so we need our negation. There has not been somebody born in Antarctica. So we want to see if this statement is true. So is it true that George or Abraham Lincoln was either the first or second president, and that a United States president has not been born in Antarctica? So let's see if it's true. Okay, so if we're going to do that, we can set it up like a little truth table if we want to. P, Q, and R. You can find all 8 rows if you want to, but you don't have to. We know the truth value of each one. George Washington was indeed the first president. That is true. So underneath P, we can put true. Abraham Lincoln was not the second U.S. president. That is false. So under him, we can put false. Okay? And then R was that there was a U.S. president born in Antarctica. We know that that is a false statement. If you don't know, you can look it up. So under R, we can put false. Okay, so the first thing we need to find is we need to find if P or Q is true. Okay, so remember, if you look at P and Q, as long as one of them is true, then the OR statement is going to be true. So because the P is true, we can say that P or Q is true. We also need to find the negation of R. Since R is false, the negation of R is true. And then we need to find the conjunction of P or Q and the negation of R and see if that is a true statement or not. Since P or Q is true, and since the negation of R is true, then this entire statement is true. So you have proved that the compound statement is true.